Welcome to our deep dive into Florence-VL. You've sent me so much to go through research papers, articles, even some notes. I think it looks like we're going to try to break down this potential game changer for logistics.
Yeah, definitely Florence-VL, this new family of multimodal large language models from Microsoft Research. And yeah, you're right, lots of exciting potential for logistics.
So from your notes, it seems like you're particularly interested in how Florence-VL could revolutionize warehouse operations. Like warehouses could be smarter, faster, more efficient thanks to AI.
For sure, imagine a warehouse where robots are just seamlessly moving through everything. Inventory management is like that fast, and quality control is automated in a way we haven't really seen before. That's what Florence-VL could do.
Okay, I'm already interested. But before we get too far ahead of ourselves, let's explain what makes Florence-VL so special. We are talking about cutting-edge AI here.
Well, what makes it stand out is its ability to understand images and text, especially for logistics. Like a worker who can see what's happening, read instructions, look at labels, and make decisions based on all of that.
Okay, I'm starting to get it, but let's get more specific. Imagine you're running a busy warehouse.
Mm.
What are the biggest things you're dealing with every day?
Mm. The biggest pain points would be inventory management, order fulfillment, and quality control, and always safety and security for the whole operation. These are the areas where older systems just don't work as well. It leads to errors, slowdowns, and even risks.
So that's where Florence-VL comes in, right? How could this AI help with a real warehouse?
Okay, let's start with inventory management, always a challenge. Florence-VL can use its vision to track inventory automatically, like giving your warehouse a set of eyes that can see each box, read every label, and know what's there and where it is.
So no more manually counting things or searching for lost items. Sounds great. What about picking and packing? That seems like a nightmare.
You're right. But imagine robots or workers moving perfectly through the warehouse thanks to Florence-VL's instructions.
Right.
Like GPS, but for your warehouse, telling workers exactly what to grab, optimizing routes, minimizing errors.
That'd be amazing. Fewer errors, faster fulfillment, happier customers.
Now, what about quality control? Can Florence-VL really make sure everything leaving the warehouse is perfect?
Definitely think of Florence-VL as an inspector, checking each product for any little problem or packaging mistake. Being able to find any tiny error would really improve quality and reduce returns. That's time, money, headaches all saved.
Okay, efficiency, quality, safety, all improved. But how is Florence-VL so much smarter than other MLLMs?
Well, there are some key things. It uses a different type of vision encoder called a generative vision encoder. It's called Florence2's. It's basically like giving the model better eyes that can see with more depth and understanding.
So not just processing images, but understanding them. I want to know more about this, Florence-2. How does that help?
Well, lots of MLMs use CLIP-style vision transformers, which is kind of like trying to see a whole scene with just one quick look. Florence2 is more like an artist who sketches the scene, capturing every detail. It's that ability to create a richer representation of what it sees that makes Florence2 so special. So this deeper level of visual understanding helps with things like moving around a warehouse or doing quality control. What else is there?
The other innovation is depth-breadth fusion, or DB fusion. This is really cool.
Okay, DB fusion, what is it? Why is it important?
Okay, imagine you're trying to understand a complex scene. You wouldn't just look at it once, right? You'd walk around, look from different sides, zoom in on details, and get a sense of the whole thing.
Right, so is that what DB fusion lets Florence-VL do?
Exactly. DB fusion lets Florence-VL analyze images from different angles. It combines information from different layers, getting both tiny details and the big picture. It's like asking the model different questions about the image. Describe the scene. What text do you see? Where are the objects? By putting these different perspectives together, DB Fusion really understands the image.
So it's like different experts looking at the image, each with their own view, and then DB fusion brings all that together.
Perfect analogy. And this is how Florence-VL can be better than other MLLMs at many tasks, especially ones involving text within images like reading labels in a warehouse or complicated instructions. This DB Fusion sounds like a real game changer. But what about the visual features that Florence-VL uses? We're talking about image captions, OCR, and grounding. Can you explain how those help Florence-VL understand what it sees?
Of course. Let's start with the detailed image caption feature. Imagine you give Florence-VL an image and tell it to describe what it sees. It's like the model painting a picture with words showing what's happening in the scene. For example, it might say, this is a busy warehouse with rows of shelves filled with all kinds of products.
So it's like getting a summary of the scene, setting things up for more analysis.
Exactly. Now let's say you want more detail. You can ask Florence-VL to give me the text you see. This is the OCR feature where it reads text inside images. It can read labels, barcodes, signs, anything.
So it's like a super scanner that not only sees letters but understands what they mean. This is great for warehouses where so much info is in text.
Absolutely.
Right.
Now, for even more understanding, there's the grounding feature.
Yeah.
It's like asking Florence-VL, find the objects and describe them. This is all about spatial awareness. It helps the model understand where everything is. So not just seeing a forklift, but knowing it's next to a pallet, which is by the loading dock, like a mental map of the whole warehouse.
Exactly. And by putting these three features together, captions, OCR, and grounding Florence-VL really understands images. It's like a team of experts each adding their perspective to get a complete picture.
Sounds like Florence-VL has a really complete way of understanding images. It uses different levels of analysis to get a much better view of the world. But how does it compare to other models, especially those using the CIOP-style vision transformers? What are the big differences?
Great question. The main difference is in how they get visual information. CLIP-style models usually try to find one main representation of an image. But Florence-VL, with its generative vision encoder and DB fusion, goes much deeper.
So it's about seeing the complexity instead of simplifying it.
Yes. Think of it like the CLIP is like trying to summarize a whole book in one sentence. You get the idea, but miss a lot of detail.
And Florence-VL is reading every chapter, underlining important parts, really getting into the story.
Exactly. It gets so much more information and sees how different parts of the image connect. That makes it way better for things like moving around a warehouse or quality control.
And the research shows that, right? Florence-VL is better than models using CLIP, especially when it comes to text and images.
Yes, definitely. Its performance on things like OCR and charts really shows how much better its approach is.
Okay, so we see that Florence-VL is a big step forward in MLLMs, especially for complex, real-world stuff like automating warehouses.
Exactly. Florence-VL understanding images and text opens up a whole new world of possibilities for logistics and even beyond that.
It sounds like Florence-VL could change how we think about warehouses, making them smarter, faster, safer, and more efficient. But I have to ask, what are some challenges or things that need to be improved as it keeps developing?
That's a really good question. And remember, Florence-VL is still being developed. One big challenge is how much computing power it needs. These models need a lot of processing power, which can be tough for real-time uses.
Right, if a robot is waiting for instructions, it can't wait forever for the model to think. So making these models faster and less demanding is important.
Definitely. Another challenge is needing tons of data to train these models. Getting all that data can be expensive and take a lot of time. Finding ways to train with less data is really important for more people to use it.
So we need to make these models smarter and more efficient without using as much data. What else should we be watching for as Florence-VL grows?
Well, as they get more advanced and part of our lives, we have to make sure they're used ethically and responsibly. That means watching for bias in the data, making sure things are fair and transparent, and protecting privacy.
Those are all important things. It sounds like the future of Florence-VL has both amazing potential and big challenges.
For sure. It's exciting to be following this field, and I'm really interested to see how Florence-VL changes and shapes the future of AI in logistics and beyond.
We've talked about how Florence-VL could change warehouses, but you also mentioned the challenges of training these AI models. I want to understand the research process more. What can you tell me about how they trained and measured Florence-VL?
Great question. One key thing is the training process itself. It's not just giving the model data, it's about the right data and training it in a way that really unlocks its power. It's like baking, you need the right ingredients and the right recipe to make something amazing.
So it's not just the data, but how you use it to teach the model. Walk me through how they trained Florence-VL. What were the main steps?
They used a two-stage process. First, they pre-trained it on a huge data set of image captions, like giving Florence-VL a crash course in connecting words and pictures. This step helped the vision encoder Florence2 and the language model work together.
So they're teaching the model to see the world and describe it the way we do. Pretty amazing. What happened after that? How did they make it even better?
After pre-training, they fine-tuned it using special instruction tuning datasets, like sending Florence-VL to a special school to learn how to understand and respond to all kinds of instructions.
So taking that general understanding and making it super specific. Okay, how did they actually measure how well Florence-VL was doing?
They tested it using 25 different benchmarks covering lots of tasks, from basic visual question answering to more specific stuff like OCR and understanding charts.
Like the AI Olympics. How did Florence-VL do? Did it win any medals?
The results were really impressive. Florence-VL was better than lots of other MLLMs, even those using TLAP. It was even better than some models that use multiple vision encoders, showing how good Florence2 and DB Fusion are.
Wow, sounds like it's setting a new standard. But how did they measure how well the visual and text information were working together? They talk about quantitative analysis and visualizations. Can you explain those?
Sure. To measure how well things were aligned, they used something called alignment loss. Imagine trying to fit two puzzle pieces together. If they fit perfectly, that's low alignment loss. If not, that's high alignment loss.
So the better the model connects what it sees with what it understands, the lower the alignment loss. It's like making sure the model's vision and language are speaking the same language.
Exactly. And Florence-VL had much lower alignment loss compared to other models, especially those using CLIP. It's like Florence-VL is fluent in both visual and textual languages.
That's cool. It really bridges the gap between seeing and understanding. You also mentioned visualization techniques. What about those?
They use things like PCA plots to see how different features were grouped. It's like having a bunch of colorful marbles and sorting them by color. PCA plots do that for visual features, showing how different concepts are organized in the model.
So a visual map of how the model sees the world? That's neat.
Right. These visualizations showed that features from different prompts were capturing different information, which means Florence-VL is doing a good job of aligning vision and language. It's like seeing the puzzle pieces fit together.
Now, I'm curious about the tasks where Florence-VL really shines. The research mentioned it beat the competition in many benchmarks.
Yeah.
What are some examples?
Okay, let's start with visual question answering, or VQA. You show the model a picture and ask it a question about the image. It needs to understand both the image and the question.
So it's like testing if the model can understand a scene and answer questions about it just like a person. That sounds hard.
It is, and Florence-VL was consistently better than other models, especially on benchmarks that needed more complex thinking or understanding relationships between objects.
Not just seeing the trees, but understanding the whole forest.
Awesome.
Awesome. And that's important for the real world when AI needs to figure out complicated situations.
Exactly. In a warehouse, Florence-VL could not only see a forklift, but also understand it's moving a pallet to a certain place.
You said Florence-VL is really good at OCR and chart understanding.
Huh.
Can you give me some specific examples of how it's so good at those?
Sure. Imagine a system using Florence-VL that can look at medical images and read the text, like patient info or reports. This could help doctors make diagnoses faster and more accurately, which could save lives.
Wow, that's powerful.
Right.
Especially in healthcare where accuracy and speed are so important.
For sure. Or think about a system that can analyze financial documents, pull data from charts and graphs, and make summaries. This could change fields like finance and accounting. People could spend less time on spreadsheets and more time on strategy.
That would be amazing. It's exciting to think how Florence-VL could make things more efficient and free up people to focus on more creative work. But let's not forget that this tech is still new. The research mentioned some areas for improvement, like working with high-resolution images. Tell me more about that.
Okay, right now, Florence-VL works with images at a pretty low resolution, which makes it hard to see fine details, especially in complex images. It's like trying to see a painting from far away. You see the big picture, but not the small details that make it special.
So like looking at a blurry picture, you get the idea, but not the nuances.
Exactly. So to fix this, researchers are looking at ways for Florence-VL to handle higher resolution images. This would let it see even more and maybe be even better at tasks that need those details. It's like giving the model a magnifying glass.
Cool. It's exciting to think about what it will be able to do as they make it even better. But even now, Florence-VL is a big step for multimodal AI.
Absolutely. Developing Florence-VL shows how much progress is happening. It's pushing what's possible with AI and making us think about new things.
And with those advances comes so many new possibilities, changing how we interact with everything around us. But let's step back and think about the bigger picture. What about the impact of all this on society?
You're right. It's not just about the tech. It's about making sure these AI systems are used responsibly and ethically for everyone's benefit.
And that's a whole other discussion. So let's move on and talk about these bigger implications of AI, how it might affect society, and what we can do to make sure it's used for good. So we've talked about all the amazing things Florence-VL can do, especially for warehouses. But like you said, there's this bigger question of how AI is going to affect everyone.
Right. As AI gets more advanced and becomes a bigger part of our lives, we have to think about what that means, good and bad. We need to make sure it's used the right way, ethically.
Absolutely. It
Yeah.
feels like we're at the beginning of something huge, and we need to be careful. What are the most important things to think about as we move into this future with AI everywhere?
One of the biggest things is how AI will affect jobs. As AI can do more and more things that humans used to do, people are worried about losing their jobs.
Yeah. I can see that happening. Think about a warehouse run by robots using Florence-VL.
Mhm.
What happens to the people working there? We have to figure out how to make this change work for everyone.
Definitely the key is to see AI as something that helps us, not replaces us. It's not about AI versus humans. It's about how they can work together.
So robots and humans on the same team, each doing what they're best at.
Exactly. Imagine robots doing the hard, repetitive work, like moving heavy stuff, and humans doing the things that need creativity, problem solving, and working with other people. It's about changing jobs, not getting rid of them.
That's a much better way to think about it. Instead of being scared of robots, we should think about working with them to make jobs better and more interesting. But that means things have to change. What can we do to get ready for this new way of working with AI?
We need to invest in education and training so people have the skills to succeed in a world with AI. This means technical skills like data stuff and programming, but also things like thinking critically, communicating well, and being able to adapt.
So giving people the skills to work with AI, like they're AI whisperers?
Exactly. It's not just about individual people, though. Companies and governments need to create a culture of learning and give people chances to learn new skills.
So everyone needs to work together to make sure everyone benefits from AI and nobody gets left behind. That brings us to another big thing, making sure AI is developed and used in a responsible and ethical way.
Right. We need to be careful about bias in the data that's used to train these models. For example, if Florence-VL is only trained on data from warehouses in richer countries, it might not work as well in other countries where things are different.
That's a really good point. It shows why we need diverse and inclusive data that represents the real world. Otherwise, we could end up with AI that makes existing problems worse.
Exactly. And it's not just the data. We also need to think about privacy and security with AI. Think about a Florence-VL system with cameras and sensors watching everything in a warehouse. We have to protect people's privacy.
So we need to find a balance between using new technology and protecting people's rights. AI should empower us, not take away our freedom.
Exactly. And transparency is really important. We need to understand how these AI systems work, how decisions are made, and what data is being used. That's how we build trust and make sure AI is used for good.
So AI shouldn't be a mysterious black box that we just trust. We need to be able to understand it and be part of the conversation about how it's used.
Absolutely. The future of AI isn't set in stone. We decide what it will be. By talking about these things and thinking about the ethical side, we can make sure AI helps create a world that is fairer, more just, and better for everyone.
That's a great message and a perfect way to wrap up today. We've talked about so much, from the amazing things Florence-VL can do to the bigger questions about AI and society. The main thing to remember is that AI isn't something from the future. It's here right now, and it's changing the world in big ways.
And it's up to all of us to be part of that change, to be excited about it, but also to be responsible. By working together, we can use AI to create a future where technology helps us reach our full potential as humans.
I totally agree. Thank you for joining us for this deep dive into Florence-VL and multimodal AI. It's been fascinating, and I can't wait to see what happens next in this amazing field. Until next time, keep learning, keep asking questions, and keep exploring the world of AI.